What are virtual short and virtual ground in op-amp circuits? Have you ever wondered how operational amplifiers work their magic in electronic circuits? Today, we will uncover the concepts of virtual short and virtual ground, which are essential to understanding operational amplifiers. First, let's talk about virtual short. In operational amplifier circuits, a virtual short occurs when the voltages at the two input terminals, the inverting input and the non-inverting input, are nearly equal. This does not mean they are physically connected. Rather, it is a result of the operational amplifier's very high open-loop gain. When negative feedback is applied, the output adjusts to keep the difference between these input voltages extremely small, ideally zero. This means that, for all practical purposes, the two terminals behave as if they are shorted together, even though there is no actual electrical connection. Now, let's move on to virtual ground. This concept is a specific case of the virtual short. When one of the input terminals is connected to actual ground, which is 0 volts, the other input terminal is also held at 0 volts by the operational amplifier's feedback action. This creates a virtual ground node that acts like a ground point in the circuit, allowing current to flow as if it were connected to ground. You will often see virtual ground in inverting amplifier configurations. In these setups, the non-inverting input is grounded, and the inverting input is at virtual ground. This makes it easy to calculate the current flowing through the input resistor as it enters the inverting input node at 0 volts. From an electrical engineering perspective, the virtual short happens because of the operational amplifier's extremely high open-loop gain, which can exceed 100,000. Any small difference in input voltages gets amplified, driving the input difference back towards zero. Both virtual short and virtual ground simplify circuit analysis. Engineers can assume the input terminals have the same voltage and that the input currents to the operational amplifier are negligible due to the ideal operational amplifier assumption of infinite input impedance. These concepts are vital for designing negative feedback amplifier circuits, including inverting amplifiers, non-inverting amplifiers, summing amplifiers, and differential amplifiers. In practical terms, they allow for straightforward calculations of gains and currents without getting bogged down in the operational amplifier's internal complexities. In summary, the virtual short means that the input terminals of an operational amplifier are at nearly the same voltage due to high gain and negative feedback. The virtual ground is a node held at ground potential by the operational amplifier's feedback, even though it is not physically connected to ground. Understanding these concepts is key to mastering operational amplifier circuits in electronics and embedded systems.